This is my pre-algebra course. Today we're going to review for test number 3. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. As usual, to prepare for the test, we're going to take 2 practice exams. One we're going to take together right now, and one you're going to do for homework. So let's get started. Solve. What does it mean to solve? That means you want to find what x is. So when you have variables on both sides of the equation, you need to put the variables on one side. So I'm going to take this 6x and I'm going to put it on the other side. So I'm going to perform an operation on both sides of the equation, so I have to rewrite the equation. And to get rid of that 6x and put it on the other side, I'm going to subtract 6x from both sides. So that was the first step. Now we're going to perform an operation on both sides of the equation again, so we have to rewrite. Again, you must rewrite whenever you perform an operation on both sides of the equation. And that's to preserve the result of the previous step. So x is equal to positive 5. All right, number 2, the first step is going to be to simplify. So 8 plus 3 is 11. And negative 7y plus y is negative 6y. So on the first step, we didn't perform an operation on both sides of the equation, we just simplified. So now we're going to perform operations on both sides of the equation, so we have to rewrite the equation. And we can, let's see, we need to put all the y's on one side and all the normal numbers without letters on the other side. So we can put all the y's on this side, or we can put the y's on this side. It's up to you. But we prefer to stay away from negatives on your letters. Actually, it really doesn't matter, but that might make it a little easier. So we're going to add 6y to both sides, and that'll make sure that the variable term has a positive sign in front of it. So we're going to have to move this equation over. In fact, I'll move the entire equation over, because we can't really fit anything on the other side. So plus 6y. And now we have 5 plus 9y is equal to 11. So now we have to get all the normal numbers on the other side, the left side, because we put all the y's on the right side, or we combine the y's to the right side. So we're going to perform an operation on both sides of the equation, so we have to rewrite the equation. And we're going to subtract 5 from both sides of the equation. And as you can see, we don't have enough room, so that's okay. I'm not going to skip lines here. All right, and then we're going to perform an operation on both sides of the equation again, so we have to rewrite the equation. And we can reduce that fraction. 6 over 9 is equal to 2 over 3. So we got 2/3. Y is equal to 2/3. All right. So, by the way, you should be trying these problems on your own. You should be pausing the video and trying them on your own before you watch me do them. Or you can just watch me do them. It's up to you. But it's probably best for you to try these on your own. So now we have an equation with parentheses. The first step when you have an equation with parentheses is to get rid of the parentheses. And I want you to be aware that on every equation on this test and all the tests in my course, I'm going to require you to rewrite the equation every time you perform an operation on both sides of the equation to preserve the result of your previous step. But the only equations where I'm not going to force you to do that or require you to do that is equations with parentheses, because I want you to get used to what it looks like if you actually skip some steps. And because equations with parentheses require the most steps, it's most beneficial for you to do that with these types of equations. So you're not going to have to rewrite on these. So first we're going to get rid of the parentheses, so we're going to use the distribution rule to get rid of the parentheses. That means 2 times 3z and 2 times negative 5. So 2 times 3z is 6z, and 2 times negative 5 is negative 10. Now over here we have something strange because there's no coefficient here. But remember, if you just see a negative there, that means negative 1. So that means negative 1 times z plus 1. And I'm going to go ahead and just do an extra step here. First of all, I'm going to add negative 10 and 1 to get negative 9. And now we have the distribution rule, negative 1 times z and negative 1 times 1. So negative 1 times z is negative z, and negative 1 times 1 is negative 1. So basically all it does is just, that negative just changes these signs. Alright, so now we're ready to get all the z's on one side of the equation. So we're going to, normally we'd rewrite the equation at this point to preserve this step, but we're not going to do that on this problem because, again, I'm going to allow you to skip that. So I'm going to add z to both sides, and that's going to give us 7z on this side, and I'm going to add 9 to both sides, and we have 8 on that side. So see how fast I did that? Again, I'm not requiring you to rewrite the equation every step on these parenthesis problems, just to get used to what it's going to be like when you go into upper math. This is the way you're going to do it in upper math. You're not going to rewrite the equation every time you perform an operation, because that would just take forever. All right, so let's see here. We're going to divide both sides by 7, and again, I'm not going to rewrite the equation. I'm not going to show it. I'm just going to do it and then write the result. Again, this is how you would work when you go into upper math. All right, number 4. On this problem, we do have to rewrite every step because there's no parentheses. Again, that has nothing to do with the fact that there are parentheses. It just has to do with the fact that I'm making that rule that's just the way I want to do it in my course. All right, so we have to get x's on the same side, and we're going to have to add 5x to both sides to do that. So we're going to perform an operation on both sides of the equation, so we have to rewrite the equation. Add 5x to both sides. And now we have to get the normal numbers on the other side of the equation. So we're going to have to rewrite because we're going to perform an operation on both sides of the equation. Subtract 1 from both sides, and we get 2 and 4x, and then we're going to rewrite again because we're going to perform an operation on both sides of the equation, and divide both sides by 4. And since we're out of room, I'm just going to write an arrow, and it's perfectly fine to write arrows, and 2 over 4 reduces to 1/2. So let's just check that, make sure it's correct. Everything looks correct. On to number 5. Now we have an equation with parentheses. So see if you can do this one. And you don't have to rewrite the equation every time because we have parentheses. That's just my rule that I'm giving for this course. All right, so let's, if you got the answer by now, let's go ahead and do it together. So we're going to use distribution because we have parentheses. The first step in any equation with parentheses like this is to use the distribution rule. 2 times x is 2x, 2 times negative 1 is negative 2. And now we're going to simplify. 4 minus 2 is 2, and 2 minus 8 is negative 6. So I just combined all the normal numbers to get negative 6. And now we're going to have to, we would rewrite the equation because we're going to perform an operation on both sides of the equation. But again, it's just my rule in this course that if you have parentheses, I'm not going to force you to do that. So we're going to add 6 to both sides, and we're just going to write the result after we add 6 to both sides. Again, this is how you would do it in upper math courses. Now we're going to divide both sides by 2, but again, we're not going to show it. We're not going to rewrite the equation. We're just going to show the result after we divided both sides by 2. Again, this is how you would do it in upper math courses. So number 6 is another problem like that, where you're not going to rewrite every time you perform an operation on both sides of the equation. Attempt number 6, and when you come back, we'll do it together. All right, we're back. So the first step when you're solving equations with parentheses is to use the distribution rule to get rid of those parentheses. So negative 3 times 2z is negative 6z. Negative 3 times negative 3 is positive 9. All right, now we're going to simplify. 9 plus 1 is 10. And that's all we can do to simplify. So now we're going to subtract 10 from both sides. Again, we're not going to rewrite. We're just going to show the result after subtracting 10. And then we're going to divide both sides by negative 6 to get 1. Again, we didn't rewrite. We just showed the result after we divided both sides by negative 6. And why did we skip all those steps? Why did we not rewrite every time? Well, because again, that's my rule for this course. Whenever you have an equation with parentheses, I'm going to allow you to do that just to give you an idea of what it was going to be like when you take upper math courses. And also because these equations take much longer because they're just the longest equations because you have to get rid of the parentheses and then do all the other steps that you usually would do with equations with the variables on both sides. All right, I'm going to put some dividers here. So this equation does not have parentheses, so you're going to have to rewrite every time you perform an operation on both sides of the equation. So go ahead and attempt this problem, and when you come back, we'll do it together. All right, we're back. So there's nothing we can simplify, so we're going to have to go ahead and rewrite the equation immediately. And I can tell I'm not going to have enough room here, so I'm going to move this over. So now, should we put the x's on the left side or the right side? Well, normally we'd put all the x's on the right side, just because we're going to avoid the negative. So add 8x. I mean, in this situation, you put it on the right side, but in the other problems, we may have put x or the variable on the left side. On the next problems, I'm going to show you what it's like when you do it when you have a negative on the variable. It's not wrong to do it that way, but I just prefer to have a positive on the variable term. So we get 2 minus 7x and negative 2. Whoops, that should be a positive 7x. There we go. All right, so now we have all the x's on one side of the equation. Now we're going to get rid of this 2. We have to put the 2 on the other side of the equation, so we're going to subtract 2 from both sides. 7x is equal to negative 4. Then we're going to perform an operation on both sides of the equation, so we have to rewrite the equation. And we're going to divide both sides by 7. So let's move this stuff up here. And our final answer is x is equal to negative 4 over 7. All right, so now we're moving on to evaluation. So we're just going to figure out what this expression equals when x is equal to negative 8. So we're going to rewrite the expression, except we're going to plug in negative 8 for x. And that means we need a parentheses because we have two negatives next to each other. You can't put two negatives next to each other, or two positives next to each, or a positive and a negative, or even a positive and a positive without some sort of parentheses. So we plugged in negative 8, and we're going to go ahead and simplify this. Remember, PEMDAS tells us to divide first, so negative 8 divided by 2 is negative 4. And so now we have a double negative. A double negative becomes a positive. And 4 plus 4 is 8. Same thing here. We're going to plug in. Plug in for 4 for y. PEMDAS tells us to multiply first. 7 times 4 is 28, and 3 minus 28 is negative 25. Again, you should be trying these on your own. You want to pause the video and try it on your own before you see me do it. All right, so now we're going to plug in 3 for z. Now we just have to do negative 3/4 plus 1. Now this is a whole number term, so we can write it as over 1, but I'm going to move it up a little bit. Whoops. Move it up a little bit and then write it as over 1, so now it becomes a fraction. And we can use the fundamental principle of fractions to multiply both sides by 4, and we get 4 over 4. So now we have two fractions that we're adding, and they have common denominators. So negative 3/4 plus 4/4. So negative 3 plus 4 is 1. So we get 1/4. All right, number 11. So we're going to plug in 0 for x. So we're just going to rewrite the expression. But instead of x, we're going to write 0. Now notice I used the parentheses. Here's the big question. Why did I use parentheses? Well, because when a number is next to a letter, that means multiplication. And we show multiplication in algebra with parentheses. So when you have a fraction like this, you want to simplify the numerator and the denominator first before you do anything else. You don't want to divide these. That violates the order of operations. We talked about that a little bit. If you were to rewrite this expression, it would be this sum divided by parentheses with this sum. So it's just assumed that when you have a fraction, the numerator is divided by the denominator, but you have to figure out what the numerator and the denominator is first. And so you have to simplify these expressions first. Again, that's a big assumption. It looks like we're violating PEMDAS because this is division, but we're really not. So simplify the numerator first. So PEMDAS tells us to multiply first. So 5 times 0 is 0. And we'll go ahead and do that in the denominator too. 4 times 0 is 0. And of course, 0 plus 1 is 1. And 2 plus 0 is 2. So we have 1/2. All right, so now we're going to do the same thing here. We're still evaluating. So we're going to plug in 2 for x. And why are we plugging in 2? Well, because they tell us x is equal to negative 2. Did I say 2? I meant negative 2. So plug in negative 2. So PEMDAS tells us to do the parentheses first. Now notice that this 5 is right next to these parentheses. Now again, we talked about this. In the previous course, we would write across. We wouldn't just put the 5 next to the parentheses like this. We would write across, meaning we're multiplying 5 into whatever's in whatever this expression is. But in this course, in algebra, you don't use crosses anymore, so we just put the 5 right next to the parentheses. So the 5 is multiplied into all this stuff here. But again, PEMDAS tells us before we multiply, we have to do what's inside the parentheses. So negative 2 minus 1 is negative 3. That's the first step. And PEMDAS tells us to do exponents next. Again, if you forgot PEMDAS, we can write it here, PEMDAS. So we did parentheses first. Now we're going to do exponents. So negative 3 to the second power is positive 9. And I got to keep those parentheses because I'm still multiplying this expression into the 5. And then 9 times 5 is 45. We're now doing multiplication. And I need my arrows here. 45 plus 11 is 56. All right, number 13. So we're going to, again, just copy the expression and plug in 1 for y. PEMDAS tells us to do exponents first. So 1 to the second power, 1 times 1 is 1. And then PEMDAS tells us to multiply next, so 4 times 1 is 4. And 7 times 4 is 3. All right, on to number 14. So again, we're evaluating these expressions. So we're just going to copy down the expression. And then, but instead of z, we're going to write negative 4. I'm going to have to rewrite that. All right, so you can see we have a double negative. And PEMDAS tells us to do what's inside the parentheses first. So 1 minus negative 4, that's a double negative, so it becomes 1 plus 4. And then 1 plus 4 is 5. 5 to the second power is 25, because that's just 5 times 5. And 4 minus 25 is negative 21. Now you should not be using a calculator for anything in this on this test. I don't believe there's any decimals you have to worry about on this test. All right, so we're going to evaluate x squared. So we're going to copy that expression down, but instead of x, we're going to write negative 7. And negative 7 to the second power, that's negative 7 times negative 7 is 49. And we're going to copy down the expression, but instead of y, we're going to write negative 9. And negative 9 to the second power. And by the way, this 1 here, or this, excuse me, this negative, that means negative 1 times whatever this expression is here. So you can just consider that to be negative 1 times negative 9 to the second power. So negative 9 to the second power is 81, because negative 9 times negative 9 is just 81. And then we multiply 81 times negative 1, and you get negative 81. I'm going to go ahead and just write that negative 1 in front of there, so you don't get confused. So now we're going to plug in 2 for z. PEMDAS tells us to do the exponents first, so we have negative 1 times 4, because 2 to the second power is 4. 2 times 2 is 4. And I'm going to go off to the side here. Negative 1 times 4 is negative 4. So if it helps you to write that negative 1 in front of there, because again, when you have a negative in front of a variable, it's assumed the coefficient is not written, but it's assumed to be 1, negative 1. So again, let's do that on this problem. So we have negative 1x cubed, and then x is negative 2. So negative 2 to the third power is negative 2 times negative 2 is 4, and then 4 times negative 2 is negative 8. So now we have negative 1 times negative 8 is positive 8. All right, we're continuing to evaluate. There's a lot of evaluation problems on this test. So we're going to rewrite the expression, but we're going to plug in negative 2 for z. And we get 12. Rewrite the expression, but plug in negative 3 for x. Negative 3 to the second power is 9. And again, squared means the same thing as the second power, and cubed means the same thing as the third power. It's just a different way of saying it. And we get negative 36. So again, you have to follow the order of operations agreement, PEMDAS, when you evaluate these expressions. Negative 2 to the third power is negative 8. And a negative times a negative is a positive. And if you don't know what 4 times 8 is, then that means you haven't memorized your multiplication facts, and that's a huge problem. All right, on to the next one. I think you've got the point by now. Negative 1 to the third power is just negative 1 times negative 1 times negative 1, which is negative 1. Again, if you're raising a negative to a power, then if it's an odd power, your result is always going to be a negative. If it's an even power, your result is always going to be a positive. So we get negative 9. 9 times negative 1 is negative 9. All right, so we're going to copy this expression. Except we're going to plug in negative 2 for x. All right, order of operations. I can do multiple steps at once, but I'm going to try to just do it one step at a time. So PEMDAS tells us to do the parentheses first. So negative 2 plus 1 is negative 1. PEMDAS tells us to do exponents next, so we're going to do the exponents. And this 2, please understand, this 2 has nothing to do with that power. The power raises the negative 2. It does not raise this 2 over here. So do not change that leading 2. Negative 2 to the third power is negative 8. So again, we can do multiple steps at once here, but I'm just going to take it step by step. All right, 2 times negative 8 is negative 16. And now I'm going to do 2 steps at once. 4 times negative 1 is negative 4. And you can just kind of skip this and go right to the positive if you want to. And negative 6 plus 4 plus 2, because that double negative becomes a positive. As you get into upper math, you're just going to do that automatically. A lot of this math language is you're gonna condense it in your mind as you learn to speak this language and write the language. Let's see. So now negative 16 plus 4 is negative 12. Negative 12 plus 2 is negative 10. All right, number 19. Plugging in 0 for y. It's kind of a big expression here. Let's double check that, make sure everything's correct. It looks correct. So there's a lot of stuff going on here, so we can simplify the parentheses first. So 3 times 0 is 0. And we're going to go ahead and I'm going to simplify that. 3 times 0 again is 0. Again, you can do multiple steps with these expressions if you want, as long as you don't violate the order of operations agreement. All right, now we're going to simplify the parentheses. 0 plus 1 is 1. 0 minus 1 is negative 1. And because we have that negative in front there, we don't have to write this positive sign. We could write it if you wanted to write parentheses. We could do that if you want. But it's better just to write 7 minus 1/2, because that's the condensed notation that you're going to see when you go into upper math courses and engineering and science courses. So 7 minus 1/2 plus, and 1 to the second power is just 1. And 1 times 2 is, well, I should probably just show that. So now 1 times 2 is 2. All right, so 7 minus 1/2. First, let's add the 7 and the 2. We can go ahead and do that, so we get 9. So we have 9 minus 1/2. So 9, I can write that as over 1. Any whole number can be written as over 1. Now I'm going to multiply both sides of this fraction by 2 to get 18 over 2. So now I have a common denominator. And 18 over 2 minus 1 over 2 is 17 over 2. Is that an improper fraction? Yes. Can we write improper fractions in this course? Yes. You can change it into a mixed number if you want, but we just don't need to. That would be 8.5 if you change that into a mixed number. All right, on to number 20. So now we're evaluating, but we're giving the expression that we're evaluating a name. It's called E now. So we're supposed to find E if E equals mc squared and m equals negative 4 and c equals negative 5. Now it's impossible for m to be negative 4 in the real world, actually, now that I think about it, because a mass can't be negative. But it doesn't really matter. In fact, let me just change that to a positive, because that's kind of ridiculous for these to be negative. Masses can't be negative and the speed of light can't be negative. That's what that means. The mass times the speed of light squared. All right, so m is 4, and we're going to use parentheses, and c is 5. So all we have to do now is just simplify that expression. Now we could go down with the equal sign, but why go down when you can go to the right, because there's so much room over here. All right, so let's see here. Now again, we're showing parentheses here because that that tells us that we're multiplying 4 times this entire expression. If we didn't write the parentheses, it would be 4, 5 to the second power. You see the problem there? It looks like 45 to the second power. We're not raising 45 to the second power. All right, so PEMDAS tells us to do parentheses first, or exponents first. So 5 to the second power is 25, and 4 times 25 is 100. All right, find y if, I'm going to try to keep that in the window. Find y if y equals ax squared plus bx plus c, a equals 3, b equals -2, c equals 1, and x equals 2. So a lot of stuff to plug in here. So a is 3, and x is 2, and b is -2, and of course x is 2 again, and then c is 1. So I'm pretty sure I did that correctly there, just double checking. Looks correct. Now PEMDAS tells us to do exponents first. 2 to the second power is 4. Now we can just do multiple steps at once here. -2 times 2 is -4. And 3 times 4 is 12. You know what? I'm not going to skip steps there. I'm going to show every single step. I don't want to confuse you. Um, 3 times 4 is 12, and -2 times 2 is -4. And 12 minus 4 is 8. And 8 plus 1 is 9. Find a if a is equal to h times b1 plus b2 over 2. So a is equal to h, which is 1, times b1, which is 2, plus b2, which is 0. So we just have to simplify that. Remember, when you have a fraction, you have to simplify whatever's in the numerator and the denominator first. So order of operations in the numerator tells us to do parentheses first. So we're going to do 2 plus 0 is 2. And 2 times 1 is 2. And now we have 2 divided by 2 is 1. All right, on to number 22. Actually, 21b, we have part B. So again, we're just evaluating. We're trying to figure out what a equals. So 2 times w is 2, h is 4, l is 3, h is 4, h is 4, w is 2. So all we have to do is simplify that expression. And notice I can put 2 sets of parentheses, or I can just put 1 set of parentheses. I don't really need both sets. So order of operations tells us to multiply first. So 2 times 2 is 4, times 4 is 16. And 2 times 3 is 6, times 4 is 24. And 2 times 4 is 8, times 2 is 16. So we have 16 plus 24 plus 16. And we can just add those up. 16 plus 24 is 40, and 40 plus 16 is 56. All right, on to 22. It says, check the solutions below. If correct, write true. If incorrect, write false. Show the work that leads to your answer. So these are equations that somebody solved, and they came up with an answer. They say the answer to this equation, the solution to the equation, is -2. X equals -2. So we're going to check that. We're going to use our knowledge of evaluation to check that solution. So we're going to plug in -2 to the expression on the right side, or the left side, and we're going to plug in -2 the expression on the other side, the right side, Now we're going to see if these two expressions are equal once we plug in negative 2. So I'm going to write the left side, plug in negative 2 for x. And I'm going to write the right side, plug in negative 2 for x. And now we just have to simplify those expressions. All right, so let's simplify the left side. 3 times negative 2 is negative 6. Simplify the right side. Negative 2 times negative 2 is positive 4. And negative 6 plus 1 is negative 5. And 4 minus 9 is negative 5. So the answer is true, because one side of the equation equals the other side of the equation, which means that x equals negative 2 is a solution of the equation. Whoever solved that equation did it correctly. Now, I want you to understand very clearly that I'm going to require you to show all of this on your test. I don't want you to just plug this stuff plug the negative 2 in your head into this equation and do all the math and then just say true. I want you to actually show the work. I also want this part to be a part of your solution. I want you to explain. If you don't come up with these numbers, that means you didn't do the work. All right, so on to part B. Same problem. So we're going to plug in 2 for y. Now we're just going to simplify. Again, using order of operations. 14 plus 16 is 30. 30 minus 7 is 23. 4 minus 6 is negative 2. Negative 2 minus 16 is negative 18. So as you can see, that's not correct. So we put a slash through the equal sign. And we say false. So let me just double check that. 14, 16, 30, 23, negative 2 looks correct. All right, on to number 23. Same problem. We're just going to plug in the value for z. They tell us z is negative 1. And simplify both sides. So 3 times negative 1 is negative 3. We have a double negative here, so minus a negative 1 is positive 1. And technically this is multiplication here because, again, this is assumed to be negative 1 here. So that means negative 1 times negative 1 is positive 1. All right, negative 2 times negative 1 is positive 2. Negative 3 plus 1 is negative 2. Negative 2 plus 1 is negative 1. 2 plus 5 is 7. So negative 1 is not equal to 7. So we have to put a slash. And we say false. All right, on to part B. We're going to plug in 0 for x. And negative 10 times 0 is 0. 2 times 0 is 0. 8 times 0 is 0. And we end up with 9 is equal to 5, which is not true. So we say false. So those were problems where we were checking solutions. A person's tried to solve the equation, they came up with a solution, and we checked it. And we found that of all these, only one solution that the person came up with was actually correct. So you can use that method when solving the equations. In the first part of the exam, we had a lot of equations that we were solving, and you can actually use that method to check your answer. But I just want to warn you that sometimes if you get like a fraction, like 2/3, it's very difficult to plug that back in and check it. So sometimes it helps, sometimes it just creates a lot more work. So you just got to make sure that you solve the equation correctly in the first place, so you don't have to do a lot of extra arithmetic, because you have a limited amount of time for these tests. you're going to finish in under 2 hours. All right, so now we have 2 more problems here. We have big equations with parentheses. So the first step when you have an equation with parentheses is to get rid of the parentheses. And we're going to use the distribution rule to do that. And again, because this equation has parentheses, I'm going to allow you to skip, not skip steps, but just not have to show every step. You're not going to have to rewrite every time you perform an operation on both sides of the equation. So 5 times 7 and 5 times z and 5 times 2. So 5 times z is 5z, 5 times 2 is 10. Now here, you notice there's no coefficient. So that's just assumed to be 1 right there. So it's negative 1 times 3z is negative 3z. And negative 1 times negative 4 is positive 4. And here we have negative 4 times 1 and negative 4 times negative 2z. So negative 4 times 1 is negative 4. Negative 4 times negative 2z is positive 8z. Let's just double check that, make sure we got everything right. Looks correct. So now we're going to simplify. So 5z minus 3z is 2z. And 10 plus 4 is 14. And 2z plus 8z is 10z. And negative 4 plus 10 is 6. All right, so here's the part where we have to perform operations on both sides of the equation, but we're not going to rewrite. We're not going to show the operation. We're just going to show the result of the operation. I'm going to allow you to do that when you have equations with parentheses, just because I want you to see what it's going to be like when you go into upper math courses, because you're not going to have to show every single step. You may get depressed when you see in this course that you have to rewrite every time you perform an operation, because you're going to think, if I have to do that every time I want to solve an equation, upper math is going to be really tedious. Well, it's not going to be as tedious as you think, because you don't have to rewrite the equation every time you perform an operation on both sides of the equation. You just have to write the result. So I'm going to subtract 2z from both sides to get 8z, and I'm going to subtract 6 from both sides to get 8. So I did 2 steps at the same time. I performed 2 operations on the equation at the same time, and I didn't rewrite the equation. I didn't show the operation. I just showed the result after performing those two steps. I'm going to allow you to do that when you have equations with parentheses. So now, again, we're going to perform an operation on both sides of the equation, but I'm not going to require you to rewrite. So we divide both sides by 8, and we get 1. Z is equal to 1. All right, so on to 25. We have an equation with parentheses. The first step is to get rid of the parentheses using the distribution rule. So we're going to distribute. Negative 3 times y is negative 3y. Negative 3 times 2 is negative 6. 2 times 3y is 6y, and 2 times 3 is 6. So we just got rid of all those parentheses, except the parentheses on the 3 here, which you don't need the distribution rule to get rid of. Negative 2 times y is negative 2y. Negative 2 times negative 4 is positive 8. So we simplified the equation greatly just with that first step. All right, so now we're going to simplify. Negative 3y plus 6y is 3y. I'm simplifying the left side of the equation. Negative 6 plus 6 is 0, and we're left with negative 3. 10 plus 8 is 18. So now I don't have to write the positive and the parentheses here. Instead of writing plus negative 3, I can just write negative 3. All right, so now we're going to add 2y to both sides of the equation to get 5y, and we're going to add 3 to both sides of the equations to get 21. So again, I performed 2 operations on both sides of the equation at the same time, and I didn't show the operations, I just showed the result after performing those operations. All right, so now we're going to divide both sides by 5. And again, I don't show it. I just show the result after you perform the operation. So we get 21 over 5. So that was the test today. That was the practice test. So you should be experienced with a lot of this stuff if you did the homework. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for the test, go ahead and do that now. So let's go ahead and look at the homework. So here's the homework. It's another practice test. So get a screenshot of that. And here's the answers. You want to check all your answers, make sure you did everything correctly. Remember, you have to do the homework completely and correctly. So that was the class today. Be sure to get that practice test done. And remember, the practice test is not the only thing that you need to study to prepare for the exam. I know you don't want to hear that, but you need to use all of all of the classes previous to this one to study for the test. And so the test that we took today and the practice test you're going to do for homework they're not the only thing that you need to prepare for for test number 3. You need to go back to the problems that we did in the classes, and you need to do problem after problem after problem after problem until you're absolutely sure that you're going to get the right answer. Again, there's a right way to study for the test and there's a wrong way to study for the test. The wrong way is that you do a bunch of problems and you get some of them wrong, and then you on the problems where you got the wrong answer, you look at the answer and you say, okay, now I understand. Then you take the test. That's the wrong way to study for the test. The correct way to study for the test is you do a bunch of problems, and the ones that you got wrong, you figure out how to do them correctly, and you do them again until you get the right answer. Then you do more problems. And if you get problems wrong, then you figure out what you did wrong and you do more problems. And even if you get all the problems right, you still do more problems. And you keep going and going and going and doing more and more problems until you're absolutely sure that you're going to get the right answer in every one of these types of problems. That's the correct way to study. So that's the way you need to study for the test. The test is 25 questions, 4 points each, just like the practice test that we just did. And you're going to have between an hour and 2 hours to take the test, just like the first two tests in this course. So I'll look forward to seeing you in the next class. Be sure to study for that test. Do not take that test until you're absolutely sure that you're going to maximize your score. Be absolutely sure that you know how to do those problems before taking that test. Because if you take that test and you don't pass, then you're wasting your time and you're wasting my time. So I'll look forward to seeing you in the next class.